So the video we're going to look at now looks at the switchgear database, or the CPD database, Circuit Protected Devices database, found in the electrical section. Select CPD DB, and this takes us into the database, where the first thing we can do is open up a file. We then select File, Open Database, and this takes us into the CPD directory in the DB folder, and we select the database of interest. Open the database up. This will then present you with a list of devices. Updating the tables to the new formats, and this then presents the devices. You'll notice in the listing here there are some devices that are greyed out. These are effectively discontinued devices. The manufacturers no longer produce them, but you might be wanting to model a project where you actually have them in situ, or we might have some in stock, or we might want to use them. So these are marked as obsolete. You can enter a device by either double clicking on the black banding or just selecting it and selecting edit. This takes us into the device itself, and you can see here this is marked as obsolete. We go into more up-to-date devices. You can see here we have all the generic devices. So every CPD database has all of the generic devices, such as the BS88s, the AFDDs, RCBOs, etc. So if we have a look at a simple device to start with, so let's take the example of a fuse. If we select a typical BS88, go into the edit button, this takes us into the general information where we're looking at the fact that it's a BS88 type 2. We can see the size range here between 2 amps and 400 amps, the description there, the standard that these are adhering to, and the range of sizes. So this is available between 2 and 400 amps. Into the sizes button, you can see on the left hand side here the sizes, and as you change the sizes, the time fault curves, the I2T curves, and the peak cutoff curves are generated based on the sizes. So if you need to add a device, you would simply use the add button, add the data on the fault and the time tables, the I2T and the peak cutoff. When creating the time current curves, it's probably best to have about 15 or 16 points, but it does depend on the shape and the nature of the curve. If you've got a very, very shallow parabolic curve, you could probably get away with about 6 or 7 points. If it's something like a C60, where you have the exponential curve and then the vertical drop, you probably want about 15 points. So you can look at the nature of the curve and decide how many points you want to enter. Also is important is the SC rating, the pre-arcing I2T, and of course the impulse withstand, or the UIMP values for surge protection. Back in the 18th edition, when it first came out in 2008, there were requirements set up. If there are no UIMP values, it will report it as an issue in line with the tables. You can view the graphs. You can look at the graph of each size for each type of size. And of course, if you want to view the graphs in situ, you merely have to select the range of devices and then look at the graph button, and that will present you with, in this case, the BS88 fuse curves, I2T curves, and peak cutoff curves. So when the program performs its calculation, it's using all three of these. It's not just looking at the crossing of the time current curve, it uses the I2T and the peak cutoff value as well. If we look at something a little bit more complicated, such as a micrologic device, for example, an adjustable device, again, if we select the device, the entry data is obviously different, being an electronic device. If we go into the edit button again, and then go into sizes, we can see here you have the size range. So this particular device is rated at 100 amps, 160 and 250. So those are the various sizes that it's available in. And you can see here you have all the current settings. The base current setting. So the base current setting here of 1 represents, in this case, 100 amps. 0.9 represents 90 amps. So you're taking a percentage of the base current. So the adjustable rates are 90 amps, 80, 70, 63, 55, 50 and 45. And also you can see the long time delay in time and amps, short time delay in time and amps, and also whether you have the I2T ramp. So again, you can enter these values fairly quickly in here, again putting the current rating, the UIMP value or the impulse voltage value, and the SC capacity. If you wish, you can put the catalogue numbers in. These are adjustable devices, so they can be adjusted in situ when you run the program. You can manipulate the data for presentational purposes. You might want to search by manufacturer. That will sort them out in manufacturer order. When you're in the wiring program, they are usually presented in reference order, so you might want to tally with the actual program itself. They will all be in reference order. So that's a brief overview of the devices, how to enter them, and what to look for when setting up or looking at a device.